Bismillahirrahmanirrahim. I'm to start with the new course. This is color chemistry. In this course, we will learn about the chemistry of the dyes, chemistry of the pigments, how they are produced, how they are applied on textile materials like fabric, leather, nylon, etc. So, let me start. What are the colors? What are the colorants? What are the color molecules? In that aspect, I would like to start with colorant. What are the colorants? Colorants means any species that produce color are called colorants. Quite a while ago, when the chemistry was not that much extensively known, the number of molecules were not that many known to the people. People developed their own ideas, their own theories about the colorant molecules. Like very simply, they said if any molecule carries NO2, this group, that molecule will show some color. Similarly, they consider that if some molecule contains an azo group, that molecule is supposed to show some colors. Similarly, they said if some molecule contains carbonyl functionality, that is, that molecule also supposed to be a colorant, that also supposed to show a color. Similarly, some other, like they said if some molecule contains coenoid structures, these sort of compounds, then those molecules are also supposed to be the colorants. Colorants means some species which produces color. So initially, when the much chemistry was not known, only few molecules, few compounds were known. So based on their observation, they came to the conclusion that if this body is present in any molecule, that molecule will be a colorant. Or if this is present in any molecule, that molecule will show some color. Azo group, the presence of azo group can make a molecule a colorant. Similarly, the presence of carbonyl carbon functionality can make a molecule to act as a colorant. Colorant being any species that produces color, This theory, this idea was presented by a scientist called Witt. So it was called as Witt's theory, according to which the presence of certain groups can make a molecule to produce colors. He called those molecules as chromophores. Chromophores. He said if there is a molecule, let's say any sort of a molecule, and if it carries any chromophore, then it will be called as a colorant. Any chromophore. What sort of a chromophore? These 3, 4, 5 options are given. If this is present in this molecule, it will be a colorant. If this body comes into this molecule, then it can behave as a colorant. Similarly, these were. However, this theory was not last long, was not supported with solid bases, Soon it lost its applicability with the when some molecules came onto the region with the presence of such chromophores and they were not colorants, like with the discovery of the senses of the ketone the theory became invalid because this acetone was supposed to be colorless. The acetone is supposed to be, it is in fact a colorless species, colorless compound. However, according to Witt's theory, if this carbonyl functionality is present, then this molecule is supposed to be a colorant. But this molecule carries carbonyl functionality, but even then it is a colorless. So some other few examples of the same sort came up in next few years or so, which prove this theory was not based on some logics, as molecules were known with this type of functionalities, but even then they were not colorant. So soon it was realized that it has some limitation. It has a limited applicability on certain molecules only. It is valid on certain molecules, but it is not valid for a larger class of dyes, larger class of colorants. With the passage of time, people realize that the molecules which absorb electromagnetic radiations in visible region, like 400 nanometer to 700 nanometer, such molecules are supposed to behave as a colorant. Yes, with passage of time, it was came to known that the molecules which absorb electromagnetic radiation in visible region, that starts from 400 nanometer and goes to the 700 nanometer. If some molecule absorbed in this region absorbs electromagnetic radiation and then it re-emits those radiation in the form of colors, those molecules are called colorants. Then again, this theory has certain solid basis. According to this, let's say if molecules have sort of functionalities which enhances the resonance of the electrons, the resonance of the electron it causes absorption of electromagnetic radiations in visible region. So such molecules which has the valence pi electrons, and those pi electrons can show resonance, can absorb electromagnetic radiation, and then as a result of absorption of electromagnetic radiation, then they re-emit those absorbed energy in the form of different wavelength that generates colors, So such molecules were regarded as colorants. They were regarded as colorants. So every molecule that produces color, they are the colorants, but they are not the dyes. Dyes are the only molecules which can be applied to the textile material like fabric, cotton, leather, nylon, acrylic, this and that. we have seen that many colors are present in nature around us. Flowers carry a number of colors, vegetables, fruits, and the other plants around us, they carry a number of colors in them. Those colors are due to the presence of certain molecules. Definitely those molecules carries certain resonance in them, which produces their ability to absorb electromagnetic radiations. That's why those are called the colorants. So the colors which we see around us in natural entities like plants, like in animals, fruits, vegetables, flowers, they are called colorants. More specifically, they are called natural colorants. And as I told you earlier, those colorants actually are certain molecules. Specifically, they are the organic molecules which has the ability to absorb electromagnetic radiations. Colorants which can be applied to textile materials, they will be called as dyes. Those colorants which can be applied to the textile materials, they will be called as dyes. All colorants cannot be dyes, mean any molecule which gives color, which produces color. Like I've said, there are so many types of colors are present in flowers, different types of colors are present in vegetables. But you can't get the juice of the vegetable, you can't get the extract of the sunflower or any other rose petal, you can't apply them on the textile materials. So such colorants which cannot be applied on the textile material, they remain colorants, or they may be called as pigments. However, those colorants, those molecules which can be applied on the textile material like fabric, leather, etc., they will be called as dyes. What's the difference between the color and the dyes? Colorants are organic molecules. They are the colorants. However, when I would like it like organic molecules which are in fact the colorants, are converted into water soluble salts, then they become dyes, then they become a dye. A molecule is there in the flower that gives, let's say, a yellow color in the sunflowers. If you extract that out, it's a pigment because it can't be applied directly on the fabric because that's organic in nature. We have an idea that dyeing is performed. The leather or fabric is dyed using water as a medium, as a dyeing medium. So anything which has a solubility in water, that will be applied, that will be applicable to the textile material, to the fabric. If something is not soluble in water, then how we can put that molecule directly from water to the textile material? It is not possible. So in order to enhance the solubility of the colorant, we need to convert it into a salt. We have an idea salts are soluble in water, then those colorants will become soluble, water soluble salts, and they will be acting as dyes. So colorants, then they become water soluble salts, then they become dyes, and then we can apply them on fabric. Due to their solubility in aqueous media, in water, they will be easily uh, transferred from the aqueous media to the surface of the textile materials, to the textile fabric, So at the outset now, we came to know that the colorants are molecules which produces colors, but all colorants can't be dyes. Colorants can be the color producing, but they can't be dyes. For dyes, the colorant has to be water soluble salts. So salts are supposed to be the dyes. However, their organic forms are supposed to be the colorants. They are also called as the pigments. So with the passage of the time, there has been a great development in the synthesis and the application of different forms of dyes. There is a latitude of literature is available on the chemistry of dyes. What is a dye? A water soluble organic salt is supposed to be a dye. We have idea about copper sulfate, CuSO4. It's a salt, it's a water soluble. If you put it in water, it gives you blue color. Blue color, copper sulfate, it's a salt. But as we have idea, it's an inorganic. It's an inorganic salt. So it's a colorant as it produces color, but not a dye, because it can't be produced, it can't be attached on the surface of the cotton, it cannot be dyed on the surface. Cotton can't be dyed using copper sulfate. So salt is supposed to be inorganic. Inorganic salt can't be a dye. Salt has to be organic in nature. A dye should be an organic salt. If a salt is a colorant but it's a inorganic, it can be a colorant but it cannot be a dye. So what I'm trying to convey you guys is that dyes are organic salts, not the inorganic salts. So that has to be kept in mind. As I've told you, there has been a great revolution in the synthesis and the application of the dyes. Dyes are of quite many types now. I will start to discuss a few as an introductory part. A dye can be an acidic dye. It can be an acidic dye. It has an anionic structure. Let's say I can draw a molecule over here. I've given you a molecule. It's an acidic type. It's an example of an acidic dye. It's a salt, sodium salt, negative. It's an ionic part, comes from an acid. So this molecule, as I've told you, carries resonance. It carries conjugation. The molecule, the electrons can show resonance. They have a resonance path longer than enough, and for that very purpose, they can absorb electromagnetic radiation. So they can jump around through the whole system, initially absorbing light and then re-emitting them in the form of colors. Due to the presence of this group, an ionic part This is called an annex structure, and the dye is supposed to be an acidic dye. These dyes are applied on acrylic structure, acrylic materials, acrylic fabric fiber, they are applied on such. Similarly, a dye could be a basic dye. A dye could be a basic dye. It shows a cationic structure. It shows a cationic structure. These dyes are applied on fabric in acidic media. Mostly acetic acid is used along with water to make the dye path a bit acidic in nature, so that the basic dyes could be applied on the fabric. So main two types. Number one type is an acidic dye, acrylic materials. Then are the basic dyes. They are applied on fabric in acidic media. Mostly they are used for the papers, for the dyeing of the papers. In fact, then I move on. I've explained to you acidic dyes have anionic structures, could be applied on wool, silk, fabric, cotton, acrylic materials, and this is paper. Then there is another class, big class, that is called direct dyes. They are applied on fabric, silk, nylon, etc. using slightly alkaline media. Mean your aqueous media, the water should be slightly alkaline in nature. Mostly we add sodium bicarbonate, sodium carbonate, sodium chloride, etc. as auxiliaries. These are the two main types of the dyes which are frequently applied in textile industry: acidic, basic, and direct dyes. There is another class that is called reactive dyes. Such dyes, such salts, such dyes make covalent bonds with fabric, and they get fixed permanently. Fix permanently on the surface. They make covalent bond with the surface. How they form the covalent bond? Like we have an idea that the cotton fabric is made up of cellulose. Cellulose surface carries hydroxyls. Those hydroxyls undergo nucleophilic substitutions with the reactive center of the dye. If the dye is like this one, if it carries something the reactive side, it can undergo like nucleophilic substitution, and a bond is generated subsequently between dye and this functionality. So such dyes are called reactive dyes. They get fixed permanently as a result of a chemical reaction between the dye molecule and the cellulosic fiber. Then another class that is called modern dyes, then are wet dyes. Modern dyes, there are wet dyes, and there are few other classes as well. We will discuss those in detail as we will move along the course. Today in the first lecture related to the dyes, my basic idea is to make you guys familiar what are the dyes, why they are called dyes, and what is the difference between a colorant and a dye, when a colorant becomes a dye, why all colorants are not dyes. This is what I'm trying to convey you guys. Then at the same time I've given you a little bit introduction about different classes of dyes. As the course will move on, the basic idea is to look into the chemistry of the dyes regarding their production, chemistry of dyes. Let's say if I'm discussing acidic dyes, how they will be produced, its structure, how will it look like. As I've given you an example where one of the molecule carries SO3Na part. I've told you that acidic dyes are supposed to be anionic dyes as well. So how they are produced, what's the chemistry behind their synthesis. Similarly, we will move on the reactive dyes, what is the chemistry, how they are produced actually. If you want to generate an reactive dye, what steps you need to follow. Similarly, if you're interested to produce a wet dye, then what steps are need to follow, what sort of the chemical reactants you need, how to mix them, what sort of reaction will be there. So we are going to look into the proper chemistry, how the dye molecules will be synthesized. We will start inshallah with the major class, that is mainly the azo dyes. Azo dyes, inshallah. Azo dyes, you have just seen that any dye which carry this azo group, they will be called as azo dyes, and we will study their synthesis, yes, then subsequent their application on different textile materials. So basic idea will be to make you people understand how the dyes could be synthesized, how the azo group will be generated, how this group can be introduced into any other molecule. As I've told you, a dye molecule is supposed to be a molecule which carries sort of a conjugation, single double single bond, which facilitate the resonance of the electron over a longer period, a longer number of bonds, a fewer number of bonds, so that they can absorb electromagnetic radiation, and then they can emit those electromagnetic radiation in the form of different light colors. So we will be discussing about their chemistry, and then the dyes are synthetic as we produce them in the labs, as I will teach you about the different reaction. At the same time, there are natural dyes as well. We get the natural colorants from different sources, from flowers, from vegetables. We will look into their chemistry. what is the chemistry of those molecules, whether they're phenolics in nature, they carries alkalides, they are polyphenols, they are flavonoids, whatever is the chemistry. Then what kind of reactions we could use, we can perform on them to derivatize, to convert into water soluble salts, and those colorant in the nature will become water soluble dyes. Then we will be able to apply them on the textile material. So basic idea will be to make you people understand how the dyes are synthesized using different basic chemical reactions. Most of the reactions will be a like we will be dealing with the reactions of benzene at least, mostly starting from benzenes, oxidation, reductions, diazotization, and then coupling with the other coupler that should also be an aromatic for an extension of conjugation. So this is just a brief introduction about the dyes, chemistry of dyes, types of dyes, and then inshallah as the course will proceed on, I will discuss them one by one, starting with their chemistry, their synthetic chemistry, their synthesis procedures, and finally their application on textile materials. With this, I would like to thank you very much for your patience listening. Please, if you have any question, you can put those on in comment area, or you can send me through WhatsApp. Thank you very much.